Hello boys and girls, and welcome again to another science video lesson. And in this video lesson, we will going to talk about a person who changed the view on how the earth works by providing some unusual idea that will later be improved as the time passes by. So what is this particular idea and who is this scientist that we are talking about? Let's discover that one today in this science video lesson. So let's check it out. Alright, so here we are in our topic for this video lesson. The topic is from continental drift hypothesis to plate tectonics. So today we will discover what are these ideas, alright, what are these unusual ideas that give rise to this continental drift hypothesis, and the improvement of this particular idea to become the plate tectonics theory that we all know as at this point in time. All right, so in the past video lesson, we encountered plate tectonics in its different concepts. We have here the plate tectonics boundary, the three plate tectonics boundary. Then we have the evidences that supports this plate tectonics, the ocean drilling, the paleomagnetism, then the hotspots, and we have also the mechanism that drives this plate in motion. Alright, so for today, we will try to find out the person behind this continental drift hypothesis and the evidences he gathered in order to support his idea. And also, we will try to find out what is the perception of those people during his time about his idea that continents move from one place to another. All right, so let's jump right into it. All right, so a typical student like you, all right, if you take a look at the world map, you will see something very familiar or very common. All right, so we have here the South America and Africa. If you might notice that they are the coastline, the eastern coast of South America and the western coast of the Africa is somehow connected, and it forms like a piece of jigsaw puzzle that fits perfectly. All right, and you will thought the all right, and you will thought that Africa and South America was separated somehow intentionally. All right, they were separated intentionally. All right, so not only South America and Africa, but also with the other continents that you have here on this map. Okay, so during those time, 1800s, the prevailing idea is that the continents like the one that we have right here were their original position. They are immovable and they are impossible to move from one place to another. All right? So it is what it is. All right, during that time. Okay? So the North America is that original place, the South America is that is the original place of that continent, and so on and then so forth. Now, until one person changed that particular view, right? Challenged that particular view and provided some evidences that will change that view during that time. And he was Alfred Wegener. All right. So Alfred Wegener is a German meteorologist. All right. He is a German meteorologist and geophysicist. Okay, and also an astronomer. Okay, and he also published a book called The Origin of Continents and Ocean. Now, in it, all right, in it, there's an idea that revolutionized that the continents are moving. He called it the continental drift, and eventually that idea became a scientific thought during that time, which is called the continental drift hypothesis. All right, so that's the continental drift hypothesis under the book of the origin of continents and ocean. All right, so in his investigation, he is a since he is a German meteorologist. In his investigation, he found that it is impossible for the continents to be at their original position at during his time. All right, so it is impossible. So he noticed that there is something unusual with these continents, and thus he formulates this particular idea that the continents move from one place to another. So in order to support this, he traveled all around the world, all right, in order to find some evidences to support this continental drift hypothesis. So, where did that idea came from? That idea came from when he is riding a ship, like what we have right here, is riding a ship, and the ship passes through a certain ice floats, and the ice floats break once the ship passes on it, and he noticed that there is a pattern that is formed after the ship passes this ice floats, and he looked this pattern on the world map, and he see that this particular pattern are similar to the pattern created by South America and then Africa. So he noticed that these two continents are just like a jigsaw puzzle. When they are put it together, they fit perfectly. All right. So this gave an idea to him. This gave an idea to Alfred that maybe the continents were not in their original position as once thought during that time. All right. This idea was the continents are moving, and that's the reason why South America and Africa, that it looks like a piece of jigsaw puzzle. They move separately towards they move separately away from each other, and that is why they are located to what their present position right now. Okay. So, okay. So his claim, all right, based on that observation, his claim that there's a possibility that the continents move around the surface of the earth. All right, that was his claim. So he used scientific method in this particular investigation that he had during that time, and particularly he needs to find an evidence that will support his claim about the continents that is moving around the earth's surface, right? So what are the reasoning behind that one? Okay. Okay, so during that time, he has an idea that the continents, since the continents were not in their original position, he thought that the original position of the continents, they were once formed as one giant supercontinent. All right, so he called it Pangaea, or one land. All right, the ocean that surrounds this Pangaea is called Pantalasa. Right, so this is one ocean. All right. So all the continents that we know today, the seven continents that we know today, are connected long time ago all together in a one supergiant landmass called Pangaea. So according to him, this was its original position. Those the continents that we have today. Okay. So as time passes by, these continents broke apart. All right, broke apart and eventually placed to a certain position that we know right now. All right. So what are the evidences that supports that this Pangaea exists? All right. And this Pangaea exists long time ago, and the continents were certainly moving from one place to another. So let's discover what are those evidences that he gathered during the time he is investigating this idea that he came up. Okay. Okay, so the first evidence is the continental jigsaw puzzle. So, as you look at the modern map earlier, all right, that I've shown you earlier, you notice that South America and Africa are just like a piece of puzzle that was intentionally separated together, separated away from each other, and during the time that it is a part of the Pangaea, so the South America and Africa were certainly once connected to each other, and they were separated by a certain river, all right, a certain body of water at the middle. All right. So there are not only South America and Africa, but also other land masses during that time that were once today connected to a continent. For example, we have here India. India was once a continent long time ago, and before it became part of Asia. Antarctica is once located near the equator, all right? And also Australia is um, located beside Antarctica. Okay, so these are the continents. All right, these are the continent that was described by Alfred Wegener during his generation of idea about the continental drift. All right, the continental drift hypothesis. So the first evidence was the continental jigsaw puzzle. So how did he come up with this one? How did he investigate this one? So he went to South America and gathered some rocks sample on that coastline, on the eastern coastline, and also he went to Africa to gather some rock samples on the western coastline. And suddenly, he found out that these rock samples between these two continents, the rock sample here and the rock sample on this coastline, are similar, all right, to each other. Okay, based on his hypothesis. All right, so he expected that it will be similar since they are connected. So he's not wrong about that one. It is similar. Okay, so that is why the first evidence on the continental drift hypothesis is the continental jigsaw puzzle that he come up. All right, so the second evidence is not related to a jigsaw puzzle, but it is a fossil. All right, so these are fossil matches across seas. Okay, so according to him, there were some fossils that are located to a certain continent that is also present on another continent. Example, these animals that we have right here, there are, according to his investigation, he traveled to South America to find fossils of this organism that I highlighted over here. We have here the Cynognathus, and we have here the Mesosaurus, and then the Listrosaurus. And he noticed that there are some fossils found in South America. All right, so he dug up some fossils here over these areas that we have right here, and also the areas in India where he dug up the fossil of Listrosaurus. And according to his hypothesis, if South America and Africa were once connected to each other, the fossil of these two organisms that we have right here, the Cynognathus and the Mesosaurus, should be present also in Africa. All right, since they are connected long time ago. So he went to South Africa and dug up those fossils, find the places where these fossils likely to be present, and he found out that this particular place has these traces of fossils of this organism, the Cynognathus and the Mesosaurus, over this certain area that we have right over here. Okay, so over here, so he found some fossils here. He found some fossils of Mesosaurus here, and not also that, we have he also found fossils of Listrosaurus on Africa. So he thought that why is it that, okay, so during that time, the idea is that the continents was connected by land bridges because the ocean level, or the ocean water rises, the ocean level rises as time passes by. These land bridges suddenly submerge under the ocean floor. All right, so that is why, okay, people or scientific community during that time explained that the reason why there are fossils of these animals to a certain continent is because these fossils traveled through these certain land masses. All right. So, or land bridges that we have. Okay. Now, according to Alfred Wegener, that is impossible. All right. So that will be impossible. So the land bridges were that is impossible. So because now, Africa and India, there were no land bridges during that time that connects Africa and India. Okay? And also South America, it is very far, all right? It is very far to form a land bridge between the two continents. Okay. So Alfred had an idea that this continents were once connected long time ago that enables these animals that we highlighted over here to travel from South America to Africa by land. All right, and also with this one. Okay, and also the fossilized remain of the Mesosaurus is somehow okay, if land bridges are present during that time and the fossils of Mesosaurus, these are animals that lives on fresh water. They can't swim on salt water, so that is very impossible. That is very impossible for this animal to travel or to swim from South America to Africa by swimming on the salt water. So according to him, it is likely that these particular parts of South America and Africa were once connected long time ago. Not only plants or not only animals, but also plants. Like the one that we have right here, the fern named as the Glossopteris. Alright, so this is a fern. Okay. Alright, so what what makes this particular animal supports the idea of continental drift hypothesis? Number one is this thing, the Mesosaurus or this animal, is incapable of swimming in large ocean. Alright, this is a freshwater animal. So that is impossible. Okay? For it to go from South America to Africa. Alright, so we have here the Glossopteris. Okay? So the Glossopteris were, these are plants that grows on subpolar climate. These are areas near the polar region. All right. And the seeds of these plants, according to Alfred, were too large and it is impossible to be carried by wind. All right. So, according to him. So, this particular plant called Glossopteris supports the idea of continental drift hypothesis because it is impossible for its seeds to go and travel somewhere else, all right? Because it was too large, all right? It was too large for it to be carried by wind or anything. Okay. Also, all right. Also, how come that this animal that we have right here called the Listrosaurus be present on Africa, which is miles away? All right. As of today, Africa is miles away from India, so it is impossible for a land-dwelling reptile to travel to those two continents using to travel on water because Listrosaurus is a land-dwelling reptile, right? So certainly this animal also supports the idea of Alfred Wegener about continental drift, right? So that is evidence number two. Okay, the fossil matches. All right. So evidence number three is the rock types and geologic features. All right. So Alfred Wegener traveled to America and visited the Appalachian Mountains here in the eastern or western side or the eastern side of North America, and he noticed, all right, so he got some rock samples on the Appalachian Mountains here, all right, so and he went on to England to visit some mountain formation there, and he noticed that he the rock samples that he is collecting on this particular region, which is the England, is somehow similar to the rock samples that he got from North America. All right, so now he is not satisfied on that. He traveled on the Scandinavian region, the Norway, the Sweden, the Finland, and he noticed that the mountain groups on that area, the mountainous area of that peninsula or the Scandinavian nations that we had over here, he noticed that the rock samples are also the same with the rock samples he got from North America and England. Right? And he went through Greenland, and also he noticed that this particular rock samples, he got some rock samples on this eastern side, all right? On this eastern side of the Greenland, he noticed that the rock samples are also the same all throughout. So he formulated an idea. Now, how come that these rock samples were the same? If North America were miles away from United Kingdom, and also United Kingdom is miles away from Scandinavia and Greenland. All right. So one thing is for sure that these land masses, the North America, Greenland, Europe, and United Kingdom were once connected long time ago. All right, there are no other reasons why the rock samples on this area were the same. So there will be no there will be no force that will brought this rock samples over these certain land masses that we have right here by accident. So there's only one reason: these continents were once connected long time ago. So that was his third evidence: the rock types and geologic features of some areas in the earth. All right, so this is what I'm talking about earlier. Okay. Right. So also not only the mountainous area but also some rock features on the coastlines of these continents. He compared, and these rock samples, as he expect, they were the same all throughout. Okay, so it gives him an idea that these continents were truly connected long time ago. Right, that was evidence number 3. All right, evidence number 4. Right, so evidence number 4 is the ancient climates. All right, so ancient climates. So now, according to him, all right, according to him, he noticed some rocks, all right, found in this region of Africa. All right, he noticed some rocks found in this region of South America and Africa. All right, and also some parts of India and Australia. He noticed the rocks here have ice scratches. Alright? There are traces of weathering brought about by presence of glacier or ice. Alright? So the rocks is subjected to some form of weathering similar to a glacier. Alright? Similar to the rocks when it is placed on ice, or when certain is present on that particular area. Okay, so based on that particular set of evidence, he noticed that how come that these rocks, okay, his question was, how come that these rocks have these particular traces of ice weathering? Right, so glacial scratches or whatever he called it. All right, there were some weathering, okay, that happened on these rocks in this certain area. Okay, now as of today, South America is located near the equator. Africa is also somehow located near the equator, right? And also India, located near the equator, and also with Australia. So according to him, it is impossible, right? It is very impossible to have some rocks with ice scratches on this particular area if these particular continents were placed in the equator like what the continents are placed right now. So he thought that these particular areas were once located at a certain position where the development of glaciers were present, and that was the polar region. So during that time, that area of South America, this area of Africa, this area of India, and this area of Australia were once joined together in an area, the polar region, where the development of glaciers over these rocks and develop this form of weathering. Then as time passes by, as these continents move away from each other or separated away from each other, then these rocks carried these traces of glacier or glacial deposits during the time they were placed on the in the polar region. So this is evidence number 4, called the glacial deposit. So matching glacial deposits. All right. So, okay. So we have here the ancient climate. So like what we have right now today in Middle East, why there are so many oil and coal deposits in these areas that we have right here. So, according to Alfred Wegener, he thought that this area were once located in the tropical or the equator. So, if that area is located in the equator, therefore, there's a chance that that area is a tropical region million years ago. So, then, after the continents have moved, the certain climate changes over that particular area. So that is why the plants and other living creatures that lives on that particular area died off, and then they are buried underground. So that is why oil and coal deposits in the Middle East and other parts of this planet were present, and they are very unusual. It's because they were placed long time ago in a certain region called the equator and tropical region, or there is a tropical rainforest during that time on that particular area. Okay. So that is evidence number 4, called the ancient climates. All right, so those are the four evidences. So as we recall, we have evidence number 1, the shape of the continents that fits like a jigsaw puzzle. Number 2, the rocks. All right, the rocks that are found in certain continents, from America to Greenland to Scandinavia to United Kingdom. The mountain regions, the rock samples from the mountain regions, the fossils, and also the climates. All right, so the climates in a certain area, all right, in a certain area doesn't match to the climate of that certain area in modern position of that particular continent. All right, so those were the evidences that supports the claim that the continents move around in the surface of the earth. Now, as Alfred Wegener present this idea to the scientific community, all right, so guess what? The scientific community during that time didn't accept this particular idea, because there's one question that was asked on to Alfred about how is this possible? All right? What is this mechanism that enables the continent to move around? Okay, so that was the question. Okay, so the scientific community agreed about the evidence, but during that time, that question, what is the mechanism that makes this continent move from one place to another, uh, wasn't answered by Alfred Wegener. All right, there's one answered by him. It was caused by centripetal motion of the Earth. That's the reason why the continents were moving during that time. All right, so the scientific community were not satisfied with that particular explanation, okay, on how the continents were moved. So, okay, so during that time, people didn't believe about his idea about continental drift. All right, so basically, for the past 100 years, there's no idea that change, or during that time, people still stick on the idea that the continents that they knew on a certain world map was their original position during that time. Okay, so these were the reason. Okay, so people could not imagine what Earth looks like during million years ago. So only Alfred Wegener, right? Only Alfred Wegener has an idea or has an imagination that these continents will look like this. Okay, they look like a supercontinent million years ago before they become the continents that they knew. So people are not imaginative, all right? People have limited imagination during that time, all right? So the second one is people couldn't imagine the force that is great enough to move the continents, okay? So during that time, there were no ideas that will support how these continents move from one place to another. All right, and there is no idea that there are force. All right, there are force that can move the continents to their present position that we have right now. So, literally speaking, people during that time didn't accept this continental drift hypothesis by Alfred Wegener. But Alfred Wegener didn't, although he was disappointed, he didn't stop investigating, and he traveled back to Greenland. And when unfortunately he died on that certain place in Greenland while doing some investigation that will support this continental drift hypothesis that he conceptualized. So he died on a certain place, and as of now, there's a place in Greenland, all right, where his body is buried. All right, so maybe you can go there and pay a visit on that particular area. So he literally or basically Alfred Wegener died, okay, died investigating, all right, died investigating how the earth works. All right, so after 50 years of his death, after 50 years, all right, there are improvements in technology. All right, during that time, there were no sonar. All right, so that the one that we have right here is called sonar. Sonar was invented around during the World War. All right, because of the threat of German submarines. All right, to Allied ships. All right, during that time, the sonar is from the word itself, sound, navigation, and ranging. All right, it uses sound. All right, it uses sound to detect something on the underwater. Okay, excuse me. All right, so that is sonar. So during the time of Alfred, there were no technology that is similar to sonar. So because of sonar, they be able now to map the ocean floor. Right, they be able now to map the ocean floor, and people during that time expect that the ocean floor is flat. All right. So because of sonar, they gained some idea that the ocean floor is not flat. It is made up of mountainous ridges and valleys and other stuffs. All right. So now, after 50 years, these two, Maritarp and Bruce Heesen. All right, so Maritarp and Bruce Heesen. So there's, I will provide a link. All right, I will provide a link on the video lesson that I had about these two last time. So you can go there. You can click that link and visit or watch that particular video that that will feature these two people that we have right here. All right, so these two people, they use the data coming from the sonar. All right, they use the sonar data to map the ocean floor, and they come up with this particular impressive map that we have right here. That they found out that underneath, all right, underneath the Atlantic Ocean, there is a large ridge valley or large rift, all right, that separates the eastern side and then the western side of the Atlantic Ocean. All right, we called it now today as the MidAtlantic Ridge. And because of these two people that we have right here, all right, we will not have any idea that there is something like this underneath the Atlantic Ocean. All right, so the work of these two people, Maritarp and Bruce Heesen, supports the continental drift hypothesis that was conceptualized by Alfred Wegener after 50 years. All right, 50 years ago. All right, so after that one, because of the data coming from the sonar, so these two, we have, okay, so Robert Dietz and Harry Hess. Robert Dietz is here, and Harry Hess is this person here. They formulate a theory called the seafloor spreading. The seafloor spreading theory. Now, in this seafloor spreading theory, they thought that the seafloor is somehow the ridge that is present on the Atlantic Ocean is making the seafloor separating or moving away from each other. All right, they are separating or moving away from each other, and okay, as they investigate this particular concept, all right, underneath the Atlantic Ocean, all right, so they found that this seafloor spreading is really valid. All right, They found that the seafloor spreading is valid via ocean drilling, and the data from the sample of rocks that are found in the ridge in the Atlantic Ocean. So, okay, the seafloor spreading theory supports, all right, supports the continental drift hypothesis that was conceptualized by Alfred Wegener 50 years ago. Okay. All right, so we have here Fred Vine and Drummond Matthews. So this is the improvement of the seafloor spreading. So studying the paleomagnetism, all right, which are found using the magnetometer, all right, using the magnetometer that they used to scan the ocean floor. They found out some magnetic anomalies, all right, underneath the ocean floor, and they come up that the idea that the ocean floor were spreading and okay, the ocean floor was spreading, and also these particular magnetic anomalies that were present in the ocean floor gave us an idea that the continents were once placed, were once not there in their original position, as we all know. All right, they moved from one place to another. All right, so that is Fred Vine and Drummond Matthews. Also, we have Tuso Wilson. All right, we have Tuso Wilson here. His idea about the hotspot volcanism. All right, his idea about the hotspot volcanism, on how the hotspot works and how can we use the hotspot in order to predict the motion of the plate and also calculate the rate of motion of that certain plate, especially the Pacific plate. So this particular idea by Tuso Wilson also supports the continental drift hypothesis that was conceptualized by Alfred Wegener 50 years ago. All right. So from all right. So from there, from those ideas, all right, from those ideas that were conceptualized in order to improve the continental drift hypothesis that was conceptualized by Alfred Wegener. From continental drift hypothesis, it became now what we all know as the plate tectonics theory. All right, so the plate tectonics theory, although it has a different, all right, it has a different okay, different words that were used, but it has the same thought. All right, it has the same thought. So according to the plate tectonics theory, that the outer mechanical layer of the earth, called the lithosphere, is constantly moving from one place to another, which were somehow similar to the idea that was conceptualized by Alfred Wegener somehow 50 years ago, after the development of the plate tectonics theory, that the continents move from one place to another. And not only that, also also something that will verify, all right, the continental drift hypothesis by Alfred Wegener is true, is the mechanism that makes the plate motion. All right, so I have a video lesson about that one, which is called the convection. All right, so during his time, he doesn't have any idea about this convection, so we cannot blame Alfred for that. Okay, so because during that time it was there is a limited technology, all right, limited technology that were used by some scientists in order to study something. So he doesn't have any idea about this convection currents, all right, about these convection currents, the slab pull and then the slab push. He doesn't have any idea about this one. So that is why he cannot answer, all right, he cannot answer the question during his time about his continental drift hypothesis. What is the mechanism of plate motion? All right. But now, if you were asked about that same question, you can now answer. Okay, we have now an answer to that question, and that was the convection current in the mantle that allows the plate to move from one place to another. All right, so this is Alfred Wegener, a very dedicated meteorologist, scientist, geologist. All right, during his time, one of the greatest minds, all right, one of the greatest minds that we have. So he conceptualized an idea where no one had any idea about the things he conceptualized. All right, where there is no idea about how continents are moving and so on and then so forth. So He's one of the great minds during his era, and somehow we thank him, right? We thank him because without his concept, okay, without his concept about continental drift, maybe we do not have plate tectonics theory that we use or we can study right now. So Alfred Wegener, he gave us an idea on how the Earth works, and one of the great minds of this of his era. All right, so from him, we are like a judge confronted by a defendant who declines to answer, and we must determine the truth from circumstantial evidence. All right, so it's the same thing that happened to him during the time that he cannot answer the question how the plate or how these continents move. What is the mechanism that makes this continent moving? So you cannot answer that one. Okay, same thing with that quote that we have right here. All right, so that was Alfred Wegener and his continental drift hypothesis. All right, so to summarize the lesson or the video lesson that we have here today. All right, so we have the continental drift hypothesis, which is conceptualized by Alfred Wegener himself. Okay, according to this hypothesis, that the continents move from one place to another. Alright, so the evidence that supports the continental drift hypothesis were the following. Number one is the Jigsaw puzzle fit of the continents. Number two, the fossil matches across seas. And number three, the glacial deposits or the climate, alright, ancient climates, alright, of certain continents. And number three, rock samples, alright. So rock samples that were very similar across continents. All right. So those are the four evidences that supports his continental drift hypothesis. And the continental drift hypothesis during that time were limited to certain technology that will identify certain loopholes. Okay, on this idea, especially on the mechanism on how the plate moves. All right, and also, in this video lesson, we discuss the improvement of the idea over time from the idea coming from Marie Tarp and Bruce Heesen, all right, Harry Hess, Robert Dietz, Fred Vine, Drummond Matthews, Tuzo Wilson, all right, coming from their ideas, okay, it improves the continental drift hypothesis, and what we know right now, we called it now as the plate tectonics theory. All right. So these are the four things. I hope you did get some value coming from these four things that we have learned from this video lesson. So if you learned these four things, all right, if you learned these four things all together, all right, so let's give it a high five. All right, so high five everyone. Yan. Okay, so all right, so that ends up our video lesson. Alright, so that ends up our video lesson for today. So I hope you did learn something about Alfred Wegener and his continental drift hypothesis. So if you did learn something from this lesson, just hit the thumbs up on this video. And if you want to, alright, so if you want to ask a question, just write it down. Just put it down in the comment section below this video. Or if you want to suggest what kind of topic, okay, do you want me to discuss in future video lesson, just write it down or type it down in the comment section below. So don't forget to subscribe on my channel and hit the notification bell for you to be updated with new contents about science stuff, anything and everything about science. All right, so just subscribe. It will help me a lot in the future video lessons to come. All right, so that's it, guys. So let's see each other on the next video lesson, and I hope you did learn something new from this video lesson that we have right here. So stay safe, guys, and be productive.
Bakani tayi のね